Good afternoon. My name is Hurson from University of Missouri, Rolla. I have the privilege of chairing the last session. Apparently, Marwan kept the best for the last. We have three outstanding papers. The first paper is written by, my apology if I cannot pronounce your name properly, Ruchika, Malhotra, and Megha, Khanna. Dr. Ruchika Malhotra is the visiting professor at Indiana University, Purdue, Indianapolis. And she is going to give us a talk about software engineering predictive modeling using search-based.
Yeah, today my talk is titled Software Engineering Predictive Modeling Using Search-Based Technique. It's a systematic review and will provide future direction in this area. It is co-authored with Ms. Megha Khanna, who is working as assistant professor in Acharya Narendra Dev College, University of Delhi, India. I will cover the following parts in my presentation: motivation behind this work, the background behind this work, the review process which I followed in order to conduct the systematic review, the research results which were formed from the systematic review, conclusion, future direction, and finally some references. First, I will begin with motivation of the work. Software engineering predictive modeling involves constructing models with the help of various independent variables or predictor variables. The aim is to predict something which is known as dependent variable for estimating, and in our case the dependent variable is various quality attributes such as fault proneness, change proneness, effort, reliability, maintainability, etc. The prediction process generally involves the training of a learner using past data or historical data. This trained learner can be used to predict various quality attributes of the software system developed in future. The prediction process involves the training of a learner using historical data. Now, search-based techniques are, as in the morning, the speaker gave a very good introduction about these techniques. They are capable of searching for an optimized solution in a large sample space for potential solutions. They are modeled on the basis of fitness functions, and these fitness functions generally are performance measures such as accuracy, precision, area under the curve, etc. in case of software engineering predictive modeling. Search-based techniques have gained importance in the field of predictive modeling in the past, and project managers are keen to identify optimal solutions and yield a better understanding of existing problems. Mark Herman and Clark in 2004 have stated that performance metrics such as accuracy, precision, sensitivity, specificity, or recall, area under the curve can be used as fitness functions in these techniques and hence can be used to create software engineering predictive models. Despite the usefulness of applicability of these techniques, they have not been evaluated much. So in this study, we perform a systematic review taking into account of three quality attributes: software effort, software defect prediction, and software change proneness. It is necessary to systematically summarize the current empirical so that we can derive future directions from the existing literature on the use of search-based techniques. This will allow us to raise important issues related to these techniques and provide future directions to researchers so that more and more studies can be conducted in future. First, I'll begin with what is software quality, what are quality attributes, and what are the basics of search-based techniques. Software quality normally defines as the degree or extent to which the software meets the customer requirements. There is no single term or factor that can be used to judge the quality of the system. That means software quality consists of various attributes such as functionality, usability, testability, reliability, maintainability, and adaptability. These attributes can be further divided into various categories, such as for functionality, we can include completeness, security, traceability, efficiency. Similarly, usability can be further divided into learnability, operability, user friendliness, customer satisfaction, and so on. Now, what is predictive modeling? This is a general framework for predictive modeling, where we do collect data, whether from open source repositories, from industry, or from academic environment. This data is divided into two parts: training data and testing data. And a series of pre-processing techniques are applied on the data, followed by the selection of attributes, model prediction using machine learning or search-based techniques, validating the model using the testing data, and finally applying statistical tests such as Friedman test, followed by post-hoc analysis such as Refactoring and Emani test. So this is a general framework which is followed in software engineering predictive modeling. These, as I have told you, these are the three attributes, quality attributes, which we have taken into consideration in order to perform this systematic review: effort estimation, effect prediction, and change prediction. Search-based techniques. There are various advantages of using search-based techniques. First is that it avoids getting trapped into local optimal solutions. They are robust in handling new data or new samples. They allow software engineers to balance constraints and conflicts in sample space. They can effectively handle noisy data, partially inaccurate or complete or incomplete data sets. The review process which we follow in order to conduct the systematic review is proposed by Hickey, and it consists of series of steps. First is we identified the need for a review. We formulated a series of research questions which we'll answer in this review. Then we followed a search strategy which we used to collect various or identify the primary studies in the review. Then we created or developed an inclusion and exclusion criteria which was followed to include the studies in the review and exclude the study from the review. Then we performed quality analysis. That is, we created a series of quality questions and we again analyzed the studies selected based on inclusion and exclusion criteria to see whether they follow our quality criteria or not. Finally, we performed data extraction and data synthesis. That means we reported the results. So beginning with the first step, we identified the need for review. As I've already told you, it is important to have fair evaluation of all the studies relevant to the area. To carry out research, it is critical to have clarity about the questions which need to be answered so that a focused actions can be taken. Formulation of research questions is the key to carry out the research, as they let the readers know what the review intends to answer. Hence, we formulated these 4 questions which we address in the systematic review. The first question is, what are the commonly used search-based techniques for software engineering predictive modeling? Thus, taking into account 3 quality attributes: effort, effect prediction, change prediction, we surveyed, we reviewed what are the commonly used search-based techniques for software engineering predictive modeling. Our second RQ was, what is the predictive capability of search-based technique in software engineering predictive modeling? Our third question was that what is the comparative performance of models predicted using search-based technique and models predicted using traditional machine learning techniques for software engineering predictive modeling. And finally, we summarize the advantages and disadvantages of search-based techniques based on the papers, based on our selected primary studies in the systematic review. Now the search strategy. The search terms are designed by dividing the research questions into various logical units and then identifying the key search terms from the relevant papers, titles, abstracts, and keywords. The synonyms and equivalent terms for all the studies were determined. Finally, we used Boolean OR to join and compile the equivalent terms and synonyms together, and Boolean AND to join and compile major distinguishable search terms. And this is our search string. So you can see the search string consists of various words and an or operation. So this search string was used to search a vast database such as IEEE, ACM, Springer, elsewhere, various conference based on search-based software engineering in order to identify initial studies based on effort estimation, effect prediction, and change prediction. In order to gather the primary studies, number of electronic databases were searched, such as IEEE Explore, ACM Digital Library, Springer, Science Direct, and Bunny. Various search-based software engineering venues, such as Genetic and Evolutionary Computation Conference, Symposium on Search-based Software Engineering were searched. The reference list of all the collected or scanned initial studies was also scanned, you can say, in order to extract various relevant studies. The search was performed from January 1992. As in 1992, a study based on search-based technique, first study was proposed, which was based in software testing, to December 2014. This is our initial number of papers we extracted from various databases, from IEEE Explore, from ACM Digital Library, from Springer, from Science Direct, and from Wiley Online. After extracting these papers and going through the keywords, the abstract, introduction, and conclusion sections, we extracted 103 relevant studies for further analysis and scrutiny. All these studies were then subjected to inclusion and exclusion criteria. That means then we followed inclusion and exclusion criteria in order to analyze these studies. And our inclusion and exclusion criteria was, that all the studies which used search-based techniques for effort prediction, for defect prediction, and change prediction were included. All the studies which compared two or more search-based techniques or a search-based technique with another machine learning techniques were included in the review. All studies which used search-based techniques for pre-processing data were also included in the review. And our exclusion criteria was that the study based on other dependent variables, such as defect count, were not included. The studies which were based on defect proneness were only included. The studies which were reviews on search-based technique were not included. All poster papers, PhD dissertations were not included. Studies focusing on clustering techniques were not included. We only focused on studies which use supervised learning. Studies whose extended versions have been already published in journals were not included. After applying the inclusion and exclusion criteria, we formed 68 candidate studies which were selected for further assessment in further quality assessment. Now we begin with quality assessment. The first task was to create quality assessment questionnaire. And this is the questionnaire which we created. It consists of series of 15 questions. The first question was, what were the objectives of the research questions? Were the objectives of the research questions clear, concise in the study or not, in the research paper or not? Are the independent variables clearly stated in the research paper or not? Are the number and magnitude of samples analyzed suitably or not in the paper? Are the data sources and collection procedures clearly defined and stated in the paper or not? Is the use of search-based techniques, the selection of search-based technique, justified in the paper or not? Are the search-based techniques clearly categorized, defined, and described in the paper or not? Is the fitness function clearly stated in the paper or not? Are the parameter settings of search-based techniques stated clearly or not? Are the performance metrics which are used in order to analyze the model development specified clearly or not? The advantages or disadvantages of search-based techniques have been considered or not while considering or selecting a search-based technique. Is there any comparative analysis involved for the model prediction? For example, is search-based technique compared with another search-based technique or search-based technique compared with another ML technique in the study or not? Is there a description of threats to validity in the study or not? is the research methodology repeatable or not? Or in order to determine whether the research methodology is repeatable, we mean are the parameter settings of search-based technique and details about search-based technique defined in the study or not? Are the findings clearly specified and do they relate to the aim of the research or not? Is the study adequately cited in literature? That is, we also considered citation count per year for a given study. Now, in order to move on, we provided a score to each study. 1, if the study satisfied the question adequately and the answer to the question was yes. 0.5, if the study satisfied the question adequately and the answer to the question was partly. 0, if the study does not answer the question and the answer to the question was no. And after gathering all the answers to all these 15 quality questions, we summarize the percentage of yes, partly and no. So as you can see, only 44% of studies satisfied or stated the use of search-based technique. They justified why they use search-based technique in their paper. Only 23% of studies defined threats to validity section in their paper. Only 56% of studies can be said as that yes, they can be repeated. The research methodology they have stated, the parameters setting they have stated for each search-based technique they have selected in their paper is repeatable. So this was after analyzing this thing, we decided a maximum score, acceptable quality score, which we kept as 7.5. That means 50% of perfect quality score in order to select a study as candidate of priority study. So these studies were turned to be, after doing this quality analysis and giving score to these studies, we got 60 primary studies that we carried forward for the systematic review. Then we moved on to the data extraction task. In order to extract data from the selected study, we prepared a data extraction card for each study. So next step was preparation of data extraction card. The card summarized and contained all the details about the specific study, including title of the study, author name, publishing detail, dependent variables, independent variables, as well as the search-based technique used in the study. The data extraction card also listed the search questions answered by the particular study and the data required for answering this question. And finally, the final step of the review process was data synthesis. It is a systematic process to provide meaningful and accurate answers to all the search questions on the basis of data extracted. The main aim of this step was to provide an aggregation of evidence in literature to establish strong and conclusive results by evaluating both the quantitative data, such as the value of performance matrix, and qualitative data, like types of search-based techniques. A number of visualization tools were used, tables were used in order to summarize the result of the systematic review. So you can see, we began with lots of studies which were extracted from IEEE Explore, ACM, Science Direct, Springer, and after doing a thorough review, only 103 relevant studies were found. And after following the exclusion and inclusion criteria, they reduced to 68. After following the quality assessment criteria, they reduced to 60. And these 60 primary studies were taken as candidates to answer the 4 research questions which we formed in the systematic review. And out of these 60 studies, we have 38 effort estimation studies, 22 studies focused on defect prediction, 1 study was common between effort and defect. So the total is 61, but I have kept it 60 because there was 1 study which analyzed both effort and defect. And there was only 1 study on change prediction defect. Now, distribution of studies across different years. As we can see, majority of studies on effort prediction and defect prediction were carried after 2008. So 2008 to 2014 were majority of studies based on effort estimation and defect prediction carried out, which used search-based techniques. According to the figure, the most of the studies, 90% of the effort estimation and defect prediction studies were published in the year 2010. The first effort estimation study using a search-based techniques was published in 1998, and the first defect prediction study was published in 2008. So defect prediction field is much more newer as compared to the effort prediction field. However, the first study using the search-based technique for change prediction was published in 2014, which was my own work. The majority of studies, 77%, were search-based technique for software engineering predictive modeling were published between 2008 and 2014. So in order to answer our search questions, first we categorized the search-based techniques into 4 categories. First was local search type of techniques. Second was swarm intelligence type of techniques. Third category was evolutionary type of techniques, and fourth was hybrid type of techniques. So as you can see, we have first categorized the search-based techniques into 4 subcategories. Local search, which focused on hill climbing, simulated annealing, taboo search, swarm intelligence type of search, particle swarm optimization and colony optimization, artificial immune system, gene expression programming, then evolutionary algorithms, which were based on genetic algorithms, genetic programming, evolutionary programming, and finally the hybrid algorithm. Hybrid algorithm means that they combine the advantages of search-based technique as well as machine learning technique. For example, genetic algorithms support vector machines. Particle swarm optimization, artificial neural network. Genetic algorithm, artificial neural network, and other hybrid techniques. So we broadly divided the search-based techniques into 4 subparts and then into subparts, and further they can be divided. For example, we can have number of methods, number of techniques under AIS, number of techniques such as multiple objective PSO under PSO. So we first divided them into categories before moving on. After dividing them into these categories, we summarize the distribution of studies across search-based technique based on the categorization. For example, in effort, we can see 63% of studies used evolutionary techniques. 24% of studies used hybrid techniques. 8% of techniques use swarm intelligence technique, and 5% of studies use local search techniques. Similarly, in defect prediction, 45% of studies use swarm intelligence techniques. 23% of studies used evolutionary techniques. 36% of studies used hybrid techniques. And there was no study which evaluated the use of local search. So as you can see, effort estimation had majority of studies which were based on evolutionary algorithms. Defect prediction has majority of studies which were based on swarm intelligence. And change prediction, there was only one study on change prediction. It evaluated 7 search-based techniques, which included 3 evolutionary techniques and 3 hybrid techniques. That means combination of search-based technique and machine learning techniques. Now, in order to analyze the performance of these techniques, we used a series of performances. Okay. I will fast. In order to analyze the performance of search-based techniques, we have a series of performance analyzers. You must be having knowledge, so I'll skip this slide. And we used MMRE, PRED, and for defect prediction, we used area under the curve and accuracy. This is the summary of these performance analyzers. As you can see, the GANN performed the best with with 9% of minimum error, 69% of maximum error, and 27% of mean MMRE. So after analyzing these results, I just summarize the results. The most commonly used metrics for analyzing defect prediction were found to be accuracy and area under the curve, and clonal selection classifier algorithm, which is type of artificial immune system, optimization (PSO), multi-objective particle swarm optimization technique with the best results with mean area under the curve, which was 77%. The worst performing technique was clonal algorithms with a mean area under curve of 0.54, and the worst mean accuracy was given by GA, genetic algorithm support vector machine, which was a hybrid algorithm with 60% mean accuracy. For change prediction, we used accuracy, recall, precision, all the performance measures which were given by the study, and the prediction accuracy were between 62% and 82% for all the data sets. The next task was to compare the performance of search-based modeling. I'll just summarize my result. For the models developed using genetic algorithm techniques outperformed all the models when compared these data sets. Only PSO, GANN and bagging models were better than the GA model in 3 studies. The GP model was better than the CART, classification and regression technique, in all of the data sets and was worse than the PSO model in 4 data sets. However, the GP model was worse than GA, GANN hybrid technique and bagging models in majority of the data sets. Similarly, the PSO model was better than ANN and CART models in all of the data sets. Finally, the GANN was equivalent to bagging models and ANN models. For defect prediction, the models developed using multiple objective particle swarm optimization techniques were better than all other techniques except the random forest technique, which usually performs the best in machine learning among the The models developed using the AIS1 technique were better than the clonal algorithms and support vector machine models in all the data sets. However, the AIS1 models were worse than all other compared search-based techniques and ML models in majority of the data sets. Now, finally, answer to our RQ4, advantages and disadvantages of search-based techniques. The genetic programming, the advantages which were given in the research paper, more than 2 papers have only been listed. The genetic programming technique is non-parametric in nature, which is a great advantage. It can find unusual relationship by discovering data trends and is adaptive in nature. These are not my observation. I am summarizing the observations which I have obtained in more than 2 studies in case of defect prediction or in case of effort prediction. The genetic programming techniques is appropriate for high dimensional problems and vast space of cost function. It helps in identifying non-linearities of underlying data and can operate on only a small portion of data for extracting the rules. However, a few studies reported large setup time and running effort as the disadvantages of search-based technique. The genetic algorithm techniques was also was used, and the reasons given by the authors were that the assumption about the underlying data distribution was relaxed in this technique. It also was away from getting trapped into the local minima. The particle swarm optimization technique was also reported as fast conversion technique. So conclusions, the first one was the search-based technique were broadly categorized into 4 categories. The most frequently used search-based techniques for effort prediction were evolutionary and defect prediction were swarm intelligence. The most commonly evaluated performance matrix for effort were mean, magnitude, relative error, and PRED. And for defect prediction were accuracy and area under the curve. Most of the search-based techniques show prediction capability close to acceptable level for effort prediction, with MMRE value ranging between 27% to 71%, and PRED value ranging from 47% to 80%. Similarly, search-based techniques show acceptable capability for developing defect prediction models with accuracy values ranging from 63 to 86% and area under curve ranging from 0.6 to 0.7%. The GA technique performed best in case of approximation. However, the MOPSO technique and CS, the clonal-based technique, works well for defect prediction. Different search-based techniques have their corresponding characteristics, advantages, and disadvantages, which I have summarized. I'll just quickly summarize the future direction. There are limited number of studies. As you can see, I have extracted 38 in effort, 22 in defect, and If no study in pattern change prediction, only one. A large number of studies should be carried out to explore the effectiveness of search-based techniques, especially using industrial data sets. There are very few studies that assess the predictive performance of local search techniques, especially in case of defect prediction. Researchers should also explore the limitations of search-based techniques that obstruct the application of these techniques to the software industry. According to the quality analysis, I have already told you that only 56% of studies were repeatable. So the parameter settings and the fitness function should be clearly stated and completely stated so that we can replicate and repeat these studies. Practitioners should donate their data publicly so that can be used to perform these repeat these studies. Certain studies state the setup time and running time as the disadvantage for search-based techniques, but I think using parallel or cloud search-based software engineering has led to the promising result in significant time reduction. Researchers and practitioners should use search-based techniques in conjunction with already established conventional models for feature selection or parameter optimization in order to improve results. Future study may incorporate other performance evaluators such as generalization capability, cost effectiveness, ease of interpretation, and estimation accuracy metrics used in the studies. These are the few references of the study. Thank you. If you have any questions.
We have time for one question.
Thank you for your talk. I just want to about one thing is that how many of these studies, especially for defect prediction and effort prediction, how many of these studies taken into account the generalization ability of the model?
Generalization?
Ability of the model. Because you mentioned about the accuracy, yes. You know, when the root means for error or whatever the other error is. Now the question is maybe.
Generalize, yeah.
So how many of that because these studies taken into account generalization ability?
Generalization ability, you mean they have evaluated these techniques on new data sets?
No, I'm just explaining what happens in the machine learning is that if you don't, properly experiment, conduct the experiment, what happens is that your model might, give good results in the training set.
Yeah,
but
not on the validation or testing
set. How the experiments are being performed.
Yeah.
So one thing is that maybe did they use test training set only? Or did they use K-pod for validation?
Yeah, that was what I was telling you. The generalization capability means whether you have performed validation or not, testing or not. Through K-cross, maybe through K-cross, hold out, or maybe through leave one out validation. Most of them have done that. In fact, every study has done that.
But this is important, but you didn't mention actually how many of them come into
Yeah, I didn't mention it, but yes. Every study has done that.
Every study.
Yes.
Another thing I should say that regarding the interpretability of the solution, how many of the approaches taken into account, specifically when they are using genetic programming, so the interpretability of the solution, how interpretable the model is.
How? What do you mean by
how interpretable means is that the symbolic regression is very powerful, but whenever it generates a solution, in some cases it's not interpretable. Because suppose that I have a polynomial like x cube plus x square plus x plus or something like that. It's very interpretable. But the GP generated solution in some cases not.
And in fact, in most of the studies, we will not specify their parameter settings. So the interpretability is very questionable. Like studies have not mentioned this feature in there.
You should mention that. That's what I'm saying. These two things.
Any more questions?
Thank you.
Thank you so much. This is the problem with software engineers. When it comes to the hardware, then we have problems. Sure. Which is why is loose but it's short? Good. Well, our second speaker is Professor Soui from University of Tunisia. He's going to give us a talk about user interface adaptation by example. Your screen is always coming. It's on and off. So nobody should move. You want to change it this way, that way. Who has his USB drive? I did. Well, any questions? We know all your secrets. Thank you.
Thank you. First of all, I would like to greet everybody to attend this conference, and I would like to present my work about user interface adaptation by example. The outline of my presentation is the following. In the first part, I will speak about the context and research motivation. Then I will talk about the existing work about information system adaptation. Next, I will explain the basis of our proposed approach. After that, I will give the validation results. Finally, I will give the conclusions and some perspectives about our future work. In fact, the adaptive systems are and more present everywhere, at home, at work, in public places. The users of such systems are very different. They have different skills, experience, preference. The interaction platforms are also various. There are smartphone, cell phone, iPhone, and so on. And the environment interaction has several characteristics. In this context, there are many works about user modeling, design methods, tools for user interface generation. However, few works about the evaluation of service quality provided by these systems. Now I will give some definition about the adaptation. In fact, according to Kobza, different terms were used and could be classified into two categories. Adaptability, which is the capacity of the system to allow users to customize or to personalize the interface. And adaptivity, which means that the system performs automatic adaptation. To this end, several adaptive systems are proposed. We can mention, for example, travel, which is based on association rules. Tourists, which is based on multi-agent system. Gene, which is based on physiologic and intelligent system. 3D GIS, which is based on collaborative filtering, and Mover Perso, which is based on case-based reasoning. In fact, in this method, we note that the evaluation of user satisfaction is neglected. To fill up this gap, it is necessary to envisage new adaptation methods, taking in consideration the evaluation step. Now I will give the approach overview. The proposed approach uses knowledge from previously solved adaptation cases or examples. In our work, a new adaptation problem is solved using a combination of the past problem solution by an optimization process that exploits the available examples. The approach takes as input a base of examples and the current context and generates as output a target response or user adaptive interface. This method consists in decomposing the request into several sub-requests. The adaptive interface is generated by combining and adapting sub-solutions, which are parts coming from one and more existing adaptation examples using similarity function. In our work, adaptation example is seen as a trip. SR is a context, is a current context. It is decomposed into several sub-requests, with SR is related to a context attribute, for example, experience, study level, and motivation. RA is the adaptive interface, which is a finite set of user interface compounds. Each compound is described by some characteristics, for example, information density, guidance, size, or color. T is a set of mapping traces that relate set of attributes in context to their equivalence compound in adaptive interface, and this figure shows an example of adaptation trace. Concerning the problem complexity, as many context attributes and interface characteristics combination are possible, the number of traces combination is very high, with a complexity k factorial power k, with k is the number of the context attribute and the interface's characteristics. For us, the detection traces generation process is an optimization problem, and here we use genetic algorithm that has a general structure introduced in the following fugue, which has 5 steps. The first one is the generation, is the selection of initial population. The second one is the selection of the parents. The third one is crossover after mutation, and finally the generation of final population. The figure in the middle shows high-level pseudocode for genetic algorithm adaptation for our problem, and the idea is to generate or to combine sub-existing sub-solution coming from different existing solution in the base of example. Now I will present the phases of the proposed approach, and I will start by the first one, is the generation of and evaluation of the initial population. This step, this phase includes 3 steps. The first one is the generation of initial population. It takes as input the context attributes, for example, experience, age, motivation, and also the characteristics of the interface, for example, guidance, facility of memorization, density of information. In our work, each attribute of the context can take several values. For example, the experience attribute can take beginner, average, and then expert. And the characteristic of the interface can take also several values. For example, guidance can take the value low, medium, or high. In our work, each attribute of the context corresponds to a characteristic of the interface. And finally, the output of this step is a set of an randomly selected examples. The second step of this phase is the encoding. In fact, in our work, an example is implemented as a vector, where the traces are the element and the traces number that refer to adaptation possibility from the example base are the element values. This figure shows an example of encoding of a solution or a traces. The third step of the first phases is the evaluation of the traces of the initial population. In this step, we evaluate the adaptation examples from the initial population in order to estimate and discover the interesting traces. The quality of the generated solution is evaluated using the fitness function. The idea is to improve the quality of adaptation example by maximizing the function Qx, with x is the decision variable or the traces. The second phase of the proposed approach is the selection of the parents. In this phase, 2 parents examples are selected from the initial population. To guide this selection process, our method uses the fitness function to select element having the best fitness from the population that represents the best element to be reproduced in the child population. Our fitness function is calculated using the following formula in order to validate the proposed solution based on the base of example. The third phase of the proposed approach is the generation of the children population. This phase is based on 2 principal genetic operator, crossover and mutation. The crossover operator combines the genetic material of 2 parents by swapping a part of one parent with the part of other. Each child combines in fact information from both parents, but the mutation operates on only one traces, generally after crossover operator with a low probability. This figure shows an example of generation of the crossover process. which involves randomly chosen some position vector and replacing their assigned traces by randomly selected ones from the example base. For example, the traces 3 and 4 are selected for a change. Then they are assigned respectively traces 5 and 26 in places of 44 and 78. Finally, the other traces keep their adaptation traces. The final phases of the proposed approach is the evaluation of the new population. Once the reproduction and the crossover have been applied according to given probabilities, parents and children are merged. After that, the newly created generation of traces is evaluated by the fitness function. In this process, in fact, is repeated usually for a fixed number of generation, and the result of genetic algorithm is the best solution found along all generation. To evaluate the feasibility of our approach, we conducted an experiment to generate interesting adaptation example. The basic of example used in this experiment contains 90 examples. We ensured at this level that the examples are valid by manual inspection, and the evaluation here is based on the average fitness value of the best population obtained through 8 times iteration. As a result, we can conclude that when the number of iterations increase, the average fitness value of the interesting examples increase. To assess the quality of the generation of examples, we define the precision, which is the well-adapted response, by the total number of adaptation. This evaluation takes place in a research project with aims to adapt current technology according to the profiles of user. To this end, we invite each user to perform 10 requests in different contexts of use. For example, in this online product sales interface, our approach had good precision. The low precision was found is 50%. Thus confirmed that the return solution is pertinent. As a result, we can note that this acceptable result shows that our choice of the fitness function is good for the precision of the adaptation. As a conclusion, we can say that our contribution combines genetic algorithm and by-example technique. We aggregate the best adaptation possibility coming from different examples. Genetic algorithm is used for 2 benefits. The fitness function enhances the precision of our approach, and a large number of combination attributes of the context and the characteristic of the interface have to be considered. This principle makes the proposed approach as a generic solution. Our proposed methods also has limitation. We can mention, for example, that the performance of our approach depends on the availability of adaptation examples, which could be difficult to collect. As a perspective, we can mention that it is interesting to compare the proposed approach with other methods, and to consider the context as ontology, and also could be interesting to generalize the approach with other fields of application such as intelligent transport system and e-learning. And thank you for your attention.
We have time for a few questions.
You mentioned that you did a manual inspection for the 90 examples that you have used. What kind of criteria did you use? How do you understand what kind of
in fact, when we speak about 90 examples, in the base of example, these examples were proposed by an expert in the field. And this example contains different criteria of the context, for example, related to the user, for example, experience, for example, level study, motivation of user, and that can be also related to the environment, for example, luminosity of the environment. Can be also related to the platform of interaction, for example, the hardware characteristic or the software characteristic of the platform or mobile interaction platform.
Any other questions?
Yes. I believe that your examples really depends on the context, because when people are maybe using like the GUI interface, they have some specific goal in mind. So you try to include such information related to the context in your traces or in your examples in general. And also, in addition to this information related to the context, I believe that we're talking here about maybe dynamic environment that can change during the time, and you can maybe adjust your interface during the time based on the interaction and the information that you collect from the interaction between the user and the interface. So, are you going, for example, to consider this problem as a dynamic optimization problem where maybe you can adjust your interface during the time based on the traces that you are collecting at the example? So, it's two questions. The first one about maybe the clustering of your examples based on the goal that you have in mind, and the second one maybe on future work where you can consider dynamic optimization.
Yes. In fact, this contribution is the first step to consider context as a set of criteria related to this context. But in the future, it is very interesting to take in consideration the dynamic aspect of to change the context when interacting with the system. It's a good proposal, and we will work in this idea in the future.
Any other questions? Thanks so much. This is the last presentation, so. Anyway, Megha, I think you can introduce. So, actually, that's my job. I said, Megha, you can introduce while you said it's short. Since Osman is eager to be introduced, the last paper is co-authored by Hickey and Cinnéide. They are from the University of Dublin, Ireland. However, none of them are here, and the paper is going to be presented by Osman Mansour. So if you have any rotten eggs or tomatoes, you can throw it in. He is going to give a talk about search-based refactoring for layered architecture repair and initial investigation. So, I'm done.
So, yeah, I think my friend should be. So, first of all, thank you. I'm not the author, but I'll try to discuss what Dr. Mal and the co-author they're saying in this paper. Unfortunately, they couldn't make it, so we can just discuss and try to answer questions collectively. But I think we have more questions. We just try to. So this paper actually is, the title of the paper is Search-Based. So the title of the paper is Search-Based Refactoring for Layered Architecture Repair and Initial Investigation. So this is a preliminary publication of results, and authors they themselves claim that they're still working on different aspects of it, and they have given some interesting ideas on the future work also. So, structured layered architecture is one of the core components of large software systems, which we all know, and especially in a lot of modern software development. Layered architecture lies at the core of software testing, software vendors, and for a lot of other reasons, for economic reasons, benefits. So there's a lot of emphasis on layered architecture. So, but obviously, systems can never be ideal. So if we have a layered architecture, there will always be some violations. So what this paper is trying to do is address some of those problems, and they're trying to fix some of those layered architecture violations by using search-based software refactoring. So, so what authors are saying is over the year for any system, if it's following a specific architecture, there is always a risk that some violations are going to be there. So those violations, they call it a decay in the architecture. So this can be for obvious many reasons. It could be time constraints, or they want to meet some goals. Or it could be just sometimes a violation is just not avoidable to meet some specific functionality or feature. Sometimes engineers do have to do workarounds. So over the years, or over the software maintenance period, they have to. It's always a good thing to afterward go and fix those violations. So in one of the works they are discussing in the paper, they're saying there are 3 ways to actually fix a violation in our architecture. So first is called reflection modeling. So what they're saying is in reflection modeling, different software developers, they can either manually or using some automatic techniques, they can actually map different classes in a software across different layers, and then they can try to map if there are certain violations in the architecture. Let's assume there's a class or there's a component in a system which is supposed to be at layer 2. If it addresses or violates or accesses some other layers, like they can interpret it in terms of different maps. So that's called reflection modeling. So and what they're doing is like over the period when these violations are happening, they're called architecture erosion. So which is like different violations which are happening, which are not supposed to be happening, and they try to fix them later by using refactoring. So what can happen is if these violations are too much, then they are coming up with a classification called module clustering, in which instead of fixing, let's say you have 25 violations, which to fix them can be a huge effort. So in some scenario, they say if there's just too much effort to fix it, you can also go on and modify your software architecture to represent those. Like you modify your software architecture so that those violations are not classified as violations. Because at the end of the day, the main reason of having a layered architecture is to make understanding of the system easier and maintenance of the system easier. So, so this is a simple slide on highlighting what a layered architecture can actually be and what violations can be. So as you can see, so in a layered architecture, anyway, so in a layered architecture, the upper layer is supposed to access layers, like it's allowed to access layers which are below it, but a lower layer is not supposed to access components or classes belonging to layers above. So your upward arrows you can see are violations, but our ideal scenario is when layer n is accessing layer n minus 1. So but if some of the software architecture models even consider a violation when a layer n is directly accessing something which is beyond layer n minus 1. So that's also considered a software violation. But the primary violation which authors discuss in this paper is, like, which is the most high risk in their interpretation, is when n minus 1 accesses something directly above it, n or anything above it. So, so the goal of this work is, so these violations, how can we fix these violations? In simple words, this is the goal of the work. So they're using search-based software refactoring to fix these violations. So the goal of this work is determine if a search-based process can automatically refactor an eroded layer architecture to remove all layering violations. So they're using search-based refactoring on a Java system, and they're trying to fix those violations. So here is while I was reading the paper earlier today, also in the morning. So some of the things I mean, like the fitness function, like some of the things I've also seen, which can also be an interesting perspective for future research is, unlike over the last 2 days, we have discussed a lot of search-based optimization problems for application in software engineering. So authors in this, they have highlighted a very interesting point, which I think you will also realize in the next couple of slides, and which is counterintuitive to some of the discussions we had earlier in the morning. So what authors are saying is, first of all, obviously to solve any problem, the first thing you need to have is a good fitness function, or a good function which can represent the quality of your solution. So if there is something which is not good with the fitness function, doesn't matter what search space you're searching in or how active your algorithm is, you're probably not going to have something which is useful for your system. So, so what authors are like emphasizing in this paper is not only the search algorithm they're going to use, but also the search technique or search space they have. So they have highlighted something very interesting. There's search algorithms which are focusing more on local optimization, local minima, or their search algorithms focus more on finding global solution. So they highlighted something very interesting, like depending on the choice of your solution algorithm, how this can lead to different results. So to come up with a fitness function, I said for any work, you first need to come up with a fitness function. Only then you can apply search-based refactoring or any search-based
optimization to any problem. So for them, so first thing they have to do is somehow represent these violations in a mathematical form. So now one of the things which is coupling factor. So obviously, if you have a coupling between two classes which are in different layers and they have violation, so it means that's a bad thing, right? So, but now they cannot just directly apply this coupling to the problem, because now the problem is, let's say there is a class which is accessing three methods of a class which is above it. So it means there are three violations. But a normal coupling method will only consider it as a violation one. So that's something which I have highlighted. So they want to somehow represent it in terms of more. So this is a method they came up with, illegal coupling factor, which is actual number of illegal couplings over total maximum number of illegal couplings. So it means if a class is, if this is a higher level class, this is a lower layer class, if this class is accessing something from this layer, and let's say there are three classes in this layer, so total maximum violations can be 3, but it's like there is one maximum violation, so your ratio will be 1 out of 3. So this is ILCF. So and now they came up with 2 more metrics to further incorporate in their fitness function. One is ILC CMF CFM, and the other is ILCFF. So the first is for the methods, and second is for the fields. So now, so it's not only you want to see how many classes at this layer are accessing doing violations by accessing something in the upper layer. You also want to see what's the degree of those violations. I mean, like if there is one class which is doing a violation by accessing something in the upper layer, but let's say this class has 100 methods, and all of those 100 methods are doing a violation by accessing something. So it means the degree of that violation is bigger. So you want to somehow express it mathematically. So that's why the number of methods which are doing those violations, cross-layer violations, those are represented in ILCFM. And the number of, and let's say there is just one method, but it has like 25 fields in it. And all those fields, or there is a class which has 25 fields in it, and all those fields are somehow doing violation. So those are ILCFM. So in a way, all these 3 metrics together, they combine to somehow mathematically show the degree of violation in your system. So now authors having said or having come up with these metrics, they wanted to come up with a fitness function. So I'll just directly jump to the fitness function. I think we have, yeah. So before we go fitness function, so LCF and LCO. So the other thing which they say is it's not only you wanna decrease the violation, right? But if you in a situation where you're fixing something in your system and you decrease the number of violations in your system, or you might end up somehow affecting something else in the system, which which might overall degrade the quality of the code. Like there are 2 metrics, like lack of cohesion in the system and coupling in the system. So these are their quality metrics which they are using to indicate the overall quality. So they don't want to have a solution which decreases cohesion in the system or increases coupling in the system. So they're also having an extra check. So these are the extra checks for the quality metrics. So that's how this is the fitness function. So what they're doing is first they define illegal coupling, which is the 3 metrics we defined earlier: number of methods, number of fields, and the number of cross-layer violations, and the quality things which are LCF and cohesion and coupling, and together they form this into this fitness function. And now a quality solution is something which decreases the illegal coupling while having a minimum effect on the quality of the system. And now this 2 here is tricky, and authors themselves they accept this is a number they feel like it should be true. So they have to, but they've said that that's something they want to work on and that's something they want to improve. and there's something future study that. So right now they started with 2, so that they say this is the number. They want to have more weightage for the illegal coupling. So that's why they multiply this by 2. But this could be 1.5, this could be 3.5, but that's something, one of their future course of study also. But for now, in this study, it's 2. So, the refactoring which they are employing are move method, move field, and move class. So these are the 3 primary refactorings which for now they are applying the system to somehow try to improve the metrics and fix these violations. So the system they tested this approach was DSpace, which is a digital repository. It's an open source now, and it's quite a big system, and it's one of the systems which follow a layered architecture approach. And they studied the system, and it has more than 1,000 classes, a lot of lines of code, and everything. And it has a 3-layer architecture. The upper layer is application layer, which is mostly related to user interface, doing everything. The middle layer is business logic layer, where the logic of the system working, and this last layer, the lowest layer, is the storage layer, which is, because it's a digital repository, so all the storage, depending on which storage mechanism that's handled by the lowest layer. So the whole architecture, whole system is divided into 3 layers. So, so they have studied this system, and this is the overall. So now the stuff in gray is no violations. So layer 3 has 2255 accesses at layer 2, which are not a violation, but some of the layer 2 classes are accessing something at layer 3, and these are 48 violations. So now some of the layer 3 classes or components are accessing something directly at layer 1, causing 6 violations. This is good stuff, and these are 12 violations. So now they have a overall picture how many violations they have. But now moving forward, as I said before, some of the classes can access multiple methods. Some of the methods can have multiple fields which are causing violations. So these 48 violations in turn translate into 204 violations, because classes accessing multiple methods accessing multiple fields. So in total, they have a lot of violations. So what's happening is they use 3 major. So that's the interesting part I was talking about earlier, which is a sort of counterintuitive to a lot of things which we have discussed earlier also, and then we go to features which are directed. So they have used steepest climb first algorithm, set space algorithm. They have also used first accent climbing algorithm, and then also the third one they used is annealing, which is simulated annealing algorithm. So what they're saying is, so the first one is sort of like a deterministic algorithm. So it's very simple, HCS, which is steepest climb first algorithm. So what happens is you evaluate your solutions, and if a solution yields a better fitness function, you take it. Otherwise, you leave it. And you, so every time, if your starting point is same, you're always going to probably end up at the same final resolution. So that's HCS. HCF is it's not that deterministic. They have done multiple runs in it, and they explain how they've used it. And this simulated annealing is the most less deterministic. It has a bigger set space. To average, this is always going to find a local minima or local optimization. This is more towards global optimization. So this, I think, is an easier way to look at the algorithms. And what they have said is, of course, if your set space is bigger, you're probably gonna have more refactoring in your system. You're probably gonna have more violations that are being fixed in the system. So when they use more global optimization algorithms embedded in the they fixed 78% of the violations. And they were able to apply 66 refactorings as opposed to HCS. And HCF is sort of local optimization, but in a slightly bigger zone, I would say. So now in this slide, it looks SA is the best choice, the global optimization is the best choice. But when they discuss the results, they actually highlight that the best outcome is, and that's something which I was highlighting, is going to be with HCF. Because when you increase your search space too much, or you're able to access the whole system, so some of the violations which are fixed doesn't make sense in practical code. So afterwards, when they look at the results, with some of the classes that get moved to a layer in such a way that they're not supposed to be there. So like it says, SA by its nature accepts some refactoring that worsen interlayer coupling. So even though you're able to apply more refactorings, but since your search space is so much, so classes which are remotely even related, but they somehow apply refactoring. Let's say a method gets moved from class A to class B, which in terms of metrics might be very suitable solution, but actually can be not practical, or software developers might not like it. So what they're saying is HCF gave them the best results once they started analyzing their results afterwards. So, and they're saying, so the best run is with HCF, and they were only able to apply 20 refactorings, but the quality of those refactoring was like the quality of those fixes was such that those fixes made most sense. Because at the end of the day, some violations are always going to be there. At the end of the day, a software, you cannot have a perfect layered architecture. But what they managed to have with HCF was high impact fixes, or high impact fixes of the violations. So these are the preliminary results, and they're still working on it, the authors, and they have some. These are some of the fixes they have. These violations got reduced from 6 to 3. Those violations got reduced from 8 to 3, 46 to 6, and 204 to 23. So overall, so this is just for the summary of some of the fixes. 6 classes got moved from layer 2 to layer 3. Some classes got moved from layer 3 to layer 2. Authorization method moved from layer 3 to layer 2. And some of the wrong fixes were low classes moved from layer 2 to layer 3 to layer 2. So you can also visualize that to fix violation, an easier way is to just move. You can move your class, or you can move your method to upper layer, because from there it can always access layers beneath it, but it won't have to access something wrong. So these are something they're trying to explain. So what about the unresolved violations? So they're trying to say why some of those violations could not be resolved. So and they say like those cannot be solved directly using automation, but by using some other techniques like delegation, those violations can be solved, and that's something they're suggesting that once you run the system, you can always scan through high impact refactorings, and then you also can look into something, or you can come up with the rules which fix those violations, and your algorithm can perform. So I think that's the end of the paper. And any questions? Yeah.
Please join me to give you a big hand. Obviously, you don't want to go there asking them to ask you questions. I mean, email address is at the front of the paper, so hope to so you're more welcome. But anyway, if any questions are there, I'm probably not the right person. But Thank you, Osman. Session on this matter wants to say something.
Yeah, it's the end of the conference, so thanks, Dr. Hurson, for sharing this session. And thanks everyone for attending the NasBASE symposium. And, hopefully, we'll continue also having the second edition on this next year. And also, we selected some papers also for extension, etc. You will maybe receive an email about that very soon. And thanks again for attending the event, and let me know if you have any further questions. And hopefully this event was also an opportunity for building some collaboration forward. So thanks for coming again, and have a nice weekend.
So